Yeah, my name is Narasimha Raju, working as an assistant professor in CSE department. I would like to share with the course of data structures, and today just I am going to cover in this topic with introduction to data structures. Then before that, just we need to understand what is meant by data structures. Then first of all, to understand data structures, I am dividing that what is the reference of data and structure. Then structure means in a particular way I need to go for an how I can organize the data. Then before that I need to understand data. Data is nothing but it is a collection of information which can be anything in the form of raw facts and figures. Then what type of data I can take it? I can take the data according to the programming part, where I can take with a small example. Just if I want to make some construction of building, then the how the material just I can check. Then for this material, if I want to choose, then here I can specify if I want to make the example as construction of building. Here the material just I can take something like as an items and quantity and something like price. Then if the items if I want to choose, then what I can take some sand, etc., and some stones, and then bricks, like this. Just I can take these items, and this items quantity just I will be taking in the form of numbers with some 100 tons like that, and price with some 23.5 like this. Then randomly if I take the data like this, then for this data which type of structures, how I can take my data should be represented in an organization or an organized way or a particular order way. Then for this we need to perform the how the task will be completed according to the some time complexities if I want to check it. And then I can choose with the reference of the variables. Then for that we need to understand the concept of data types. Already according to the knowledge of C language, then already just we will be introducing with the data types. For if I want to take as an items, I can take some char or string references for the data types. But in string is a reference of a collection of words. Whenever if I'm taking, I can take it. And specifically if I want to represent in the form of an array, just I can take it with a char data type. And for the quantity of the values, if I'm taking with the numbers, then I can take it with a integer data type. And if I'm taking your price like a 3.23.5 or like this from 48.9 like this, then I can choose with the data type called as a float. Yes, here like that if I'm taking with the data, means this type of data I need to take it as what collection of information which can be anything in the form of raw facts and figures. Then these type of whenever data if I'm collecting, I need to put it in an organized way to make it the data to be how the space and time complexity will be effectively calculated. Then this is a simple introduction what we need to understand about the definition of data structure. And then we need to go with what is the need for data structure. Means if I want to make that data to be organized, how I can data to be represented, my data will be easily identified and I can specify. Then for this how the data implementation can be done in the part of data structures. The operations, major operations I'll be taking with merging and a representation of data in storage form, and managing and inserting and deleting, like that different operations I can perform in data structures. Then here the data modification will be easy and it will be requires with the less time, and saving storage memory space, and data representation is easy, and we are talking about something like easy access to the largest databases. Then how that largest databases just I can store in the form of databases with the data sets, and how that structure should be organized. Then for that we need to understand my introduction of data structure will be divided into two types. One is linear data structures and non-linear data structures, or we can also call it as classification of data structures. Then what about your linear data structures? Once again I can call with some static and dynamic representation, followed by non-linear data structures. Then what is the part of linear data structure? Whenever my data is represented to organized in linear order or a sequential order, one by one, then I can go with your linear data structures. For that something like examples just we are taking with some list, stacks, queues, etc., are the one of the best examples of your linear data structures. Then what about your non-linear data structures? That whenever if I want to represent my data in random order, or then with a not in a sequential order, then I can specify with a non-linear data structures. For that examples, just we are taking as a some table, trees, graphs already just we can specify. Then from that, how the classification we need to introduce with one after the another with the linear data structures and non-linear data structures. Then in the classification, if I want to take as a diagrammatic representation, then the data structures first we are dividing with a linear and non-linear. Then the what is meant by static data structure means without my static means directly just whenever if I'm taking with any fixed value, I cannot change. For that, we are taking an example called as an array. And another part of dynamic data structures, we are understanding about queues, stacks, and lists. And in the part of list, we'll be understanding with a linked list, what is meant by linked list, and what are the operations I can perform. And if I take with the non-linear data structures also, just we are understanding what the trees and graphs. But trees and graphs, we are tables. All these are the examples of non-linear data structures. Now, under the part of static data structures, if I want to understand with array, then how I can declare with a syntax of an array. Just I can take syntax of an array as something like I'm taking with a variable name or array name. Just I can specify followed with a value with the square brackets. And for this, I need to add with the data type or type. Data type, a variable name or array name, both I can represent. Just I will be indicating. And this variable name inside the bracket, we are indicating as what? I can declare it as size. Then what is this size? If in the part of your array, if I declare with the size, then I cannot increase and I cannot decrease, means it is a fixed representation. That is the reason we are calling your static data structure as an array. We cannot do any changes. Then if I want to do and every representation of my values should be changed, then I need to go with the dynamic data structure. In the part of dynamic data structures, we can choose with the queues, stacks, and linked list. Then in the part of your linked list, if I want to talk, then this is the where we can take my data in a sequential order in the form of list types. For that example, I can take a student data or an employee data in an organization. But one of the best example, I can take student data, where I can take my data in the form of one after the another in the sequential order. For the best example, I can choose it as roll numbers. Then if I take the roll numbers cannot be duplicated, but names can be duplicated. But in the case of my list, if I want to specify one after the another, then if I want to connect with my data, then I can best example, I can take a student roll list. Then in the part of the linked list, whenever we need to understand, we have with what so we have types of linked list. All these type of data structures in the next session we will be understanding about in detail about what is meant by types of linked list. Generally, we have it a single linked list, double linked list, and circle linked list. Then in the same way, if I want to take with the concept of stack, then for this just I can take this all are individual parts of your data structures according to the necessary of the user. I can use with any one of the dynamic data structures. Means if I want to take a stack with the process of a principle called as a LIFO, last in first out, means in that case I can use with this data structure called as a stack. Then if I want to take a implementation of a data structure, I want to take it as a first in first out, then I can take it with queues. And for this queues, one of the best general examples, I can take it with your train tickets or bus tickets, movie tickets, first come first serve basis. Then if I want to take my data in this type of scenarios, then I can use with the data structure called as queues. Then what about stack? Like if you're going for just for dinner or a lunch, then I can take it as a buffet plates. As to if whenever the top of the plate is not looking good, then I'll be taking with the removing that first plates and I'll be taking with the next plates. Then like bunch of chairs, all these are the general. Or for a spindle, if I take with the disk, then I can take it with your stack as an best example of your data structure. And if I want to you choose with the linked list, then I can choose with the student roll numbers as a reference of your values for linked list. And in the part of linked list, we don't have not only with a linked list, I will have with some single linked list, and we can also represent with a double, and one more, it is circular linked list. According to the data, whenever if you want to go with a to and fro with a front as well as means forward direction and backward direction, I can choose with the double linked list. And from the first element to the last element after going, then if I want to check, then I can go with the circular linked list. And then coming to the non-linear data structures. Then under non-linear data structures, we need to understand about trees and graphs. Both are called as non-linear data structures. Then what is the difference we need to understand with the part of trees and graphs? Whereas if I take a trees and graphs, both will be identified as a node structures, but the representation of tree will be taken in the form of open figure, whereas my graphs, in some cases it will be open figure as well as closed figures. Then for that, I need to understand with the non-linear data structures and what is the reference of graph. I can take it with both with the directions as well as non-directions. But whenever if I take with the tree, according to the root node, every time it will be going to the from an hierarchy from root to next levels, and it goes on like that. I can construct with any length of the trees. And this is a simple general introduction of data structures. In the next upcoming sections, we need to understand in detail about your dynamic data structures, what is meant by a linked list, and what is meant by stacks, and what is meant by queues, and what is meant by trees, like that, with the forward with the graph data structures as linear and non-linear data structures. And this is the small references, just what we need to understand with the your introduction to data structures. It is a simple representation. Why we need to go for data structures, and how we are implementing with different types of data structures with classification of linear and non-linear data structures. Thank you.